So let's talk about relationships and constraints. I'm sorry, relationships as constraints. Uh, so uh, so we've talked about these relationships that we were describing between departments and students, that we have a one-to-many relationship between departments and students. One department can have many students relate to the same department. The typical way of implementing this is by having the student table have a foreign key to the primary key of the department. Okay, and usually we declare these explicitly in the database, right? Saying that this is a primary key, this is a foreign key, and that immediately forces or tells the database to help us maintain or enforce certain rules, right? Like, for instance, if I have a student pointing to a department, I cannot delete that department, for instance, right? That's the default behavior. Otherwise, all the students would be left orphaned, right? Not pointing to any record in the department, certain things like that. Also, if I try to update the actual value of the primary key in the department, it also will stop me, right? Because you have a whole bunch of other records referring to this value, right? That also would leave you orphaned. So the referential integrity tries to enforce this constraint. So anything that the database is going to stop us, right, or it's enforcing any of these rules, we're going to refer to as a constraint. Okay. Same thing if we declare something as a date, as an integer or float or char or varchar or whatever, right? It will force me to use that data type. It won't let me update or manipulate that data unless it's within that particular data type. Yes? Again, constraint. If we add other rules like, this number has to be positive or has to be within a range or has to match this particular pattern, regular expression pattern, then again, all those are constraints. So let's look at some constraints that were available or were implied in the UML diagram, in the conceptual diagram, and see how it can be enforced or implemented in a relational diagram, right? In a relational database. So in this class diagram, we see that there's a three-way relationship between the student, section, and grade. And the combination of section and student, if you give me a particular student, a particular section, then I'll tell you what grade they got, right? So it could not be that the same student for the same section could be twice in there, right? Because it should be unique, right? So one grade. So this says this diagram implies that there is a constraint that is one grade, for a particular combination of student and section. Yes, there's an implied constraint in this conceptual diagram. Now, when we implement this and reify it, because there's no way to implement the above conceptual diagram, we have to reify it. The implementation is that we replace the verb there with the noun, right? So which is a grade assignment here, and we have three foreign keys pointing one to the grade, one to the section, and one to the student. Okay, and we think we call it a day, and we're all set. Okay, now the problem with this, right, is that this new grade assignment, okay, is not enforcing, the fact that I could have, the student section, the same combination of student section having a separate grade, right? Which makes no sense, right? That for the same section, the same student got two different grades. That makes no sense, right? So we somewhat lost the constraint, the implied constraint that was in the conceptual diagram, right? We lost it when we made it more concrete, right? We were about to go in and implement it. Okay, so the implied constraint did not make it into the resulting diagram, right? In the resulting concrete diagram. So how could we perhaps capture our original constraint, right? That was implied in there. So one way to do it is that we can fix that by taking a look at the student ID and the section ID that we're using as foreign keys, right? And add a couple more constraints. Say, hey, what if we make the combination of student ID and section ID unique, right? So we make that unique. Well, we get back our original constraint. We say, hey, there is no way that you could insert in here a record that has two unique combinations between student ID and section ID, right? We can combine them, right, by putting them and saying that this is not this is going to be a composite, a primary key that is going to be the composition of both the student ID and the section ID together. It has to be unique, right? And each one themselves could be a foreign key back to the student ID and section ID. So yes, we're back to where we left before, right? We had lost that implied constraint, but we were able to fix it by adding our own new constraint of making this combined key into a primary key. Okay. So the general principle is that you start off with a generic or conceptual diagram. We reify, right? We make it concrete, and then look for the look for the combination that we want to keep unique, and we just make a primary key out of it. Yes, right? Looks like it's easy. It turns out that it doesn't always work, right? It's a principle. It has a couple of limitations. It implies that the class diagram has all these links, right, to the original classes that we are going to replace. That the resulting reification of that conceptual dot, right, results in a table that has the foreign keys to the original classes that we could make unique. Right? It's assuming that we have that, but it's not always true. Right? That we can assume that that's actually going to be the case. Right? There'll be cases where we can't enforce certain things. Okay. It could be that in this process of going from here to here, right, that it turns out that one of these perhaps is a redundant relationship, right? That this relationship here is actually somewhere else, right? That if we keep it, it's a redundant data query, and we would want to remove it, right? To remove the redundancy. But if we remove the redundancy, then we can't enforce the original constraint. So let's take a look at an example. So here we have an example where we have a student enrolls in a section, and a course has many sections. Yes, right. This is what we had originally in our class diagram. Yes. So somebody comes along and adds the following requirement. Right. They say, okay, well, a student can enroll in a section of a course only if the student has not taken that course before. So you can only take the course once. You fail it, sorry, right? You can only take that course once. So it's a requirement. So that means that now we have to keep track on whether you already had that course or not. We weren't keeping track on whether you already had that relationship or not. So that means that somehow, right? Not only did we have a relationship of a student that enrolls with a section with a course, but we also now have to keep track on whether there is a direct relationship with the course and the student. Did you already take this course? Somehow we need to keep track of that, right? And it could be a many-to-many, right? That one student can be enrolled in many courses, and a course can be enrolled by many students. Already there's some redundancy there, right? Because we already could answer some of those questions going this way, right? Yeah, but let's play around with this a little bit, right? We want to we are deliberately causing a redundancy when you try to apply the principle, right? And we are deliberately causing a conundrum, right? That we'll see in a minute. Anyway, so reifying. If we try to reify this enrolls, right? We would replace it with a many-to-many, right? Well, I'm sorry, with several many one-to-manys, yes, because we want to remove this many-to-many that goes over here, and so have references to each one of these, right? So we end up with this enrollment table in between that has several one-to-manys pointing to the original tables, the course, the student, the section. And when we write it out, we say, okay, well, let's see, the section has a primary key, it's pointing to the course that it belongs to. So that's a one-to-many, right? The one-to-many with a course. The students, the course, they all, folks, other tables are referring to it, to them, but they are not referring to anybody, right? Which is fine. Also notice here we've applied the principle, right? We're saying that there's a unique the uniqueness of our primary key is a combination of student and course, right? And then we're pointing to the section ID, right? We're pointing to the section ID, we're pointing to the course, we're pointing to the students, and we're saying that this combination, we're enforcing this combination, so that can only ever happen that one student is in one course, and this cannot be, you cannot be in the same course twice. You cannot be in the course twice. Okay. But in this schema, we clearly have redundancy, right? There's obviously there's that cycle over there, right? And when we start looking at it, it says we start asking ourselves, well, wait a minute, you could answer the question on students and courses. You can also just travel the enrollment, passing through the section and then going up to the course, right? You can answer the same kinds of questions. What students enroll in which course, right? Again, we deliberately added this redundancy, right, to illustrate the limitations of our principle. For the principle, the student course, the uniqueness of that combination of student ID enforces the many-to-one constraint, right? But the path that goes from enroll to course is redundant because you can answer the same question if you go from the enrollment to the section and then up to the course, right? So clearly there's a redundancy. You would want to remove one of them. One of the paths needs to go, right? One of the paths needs to go. So what should we do? Should we remove the redundancy? But if you remove the redundancy, then you want to remove the redundancy because you risk inconsistency, right? Because conceptually the two paths need to give you the same answer, right? But for whatever reason, it could be that eventually you do the two queries and they don't come out exactly the same. It says, what's going on? Which query should I trust? But if you remove this path, right, you would be losing the many-to-one constraints here, right? So you kind of have like a conundrum, right? That both solutions are bad, right? That there's no way to enforce both at the same time. So if we leave the redundant field enrolled at course ID, then we risk inconsistency, right? So it could be that we can update enroll course ID with the wrong value that it's different from section course IDs. They both need to point to the same thing, right? This student is enrolled in which course? Oh, if you follow enroll.course ID, it needs to be the same value if you follow it through a different path, down to the section and then up to the course. That has to be the same, right? So we definitely want to remove one of them, right? But if we remove enroll course ID, we can't enforce the fact that this student can only be enrolled once in the course, right? So we can't enforce the business rule, right? The uniqueness of the student enrolled in a particular course. Okay, so we have those two problems. So the only thing that's left to us is either enforce it through some store procedure, right? That checks to see whenever we are inserting that we're not introducing any redundancy, right? Or that the updates to the table is through a store procedure, that we're not doing it ourselves, but a store procedure is making sure and validating that we're not introducing any bad redundancy, right? Or you could do it at the application level, right? Where through a UI or at the server level, or even at the different middle tiers, right? Where you don't allow it to happen at the front end. There's no way that the drop down will allow you to choose that options, okay? But nevertheless, even if it makes it to a server, you would check it again at the server, right? That again, this student is not enrolled in a course that happened that they were already enrolled in, right, at the application level. And finally, perhaps down at the store procedure, right, the updates are through a view, right, that triggers an insert or a store procedure that actually does the updates to the tables, right? So you never actually update the table because you could mess it up, and you leave it through a store procedure that can handle these. Okay. So yeah, so there are limitations of what we could enforce through the constraints that are available to us through the database.
Hi everyone, Jose here. Please remember to subscribe and like the video. And if you have any questions, please leave a comment down below. Thank you.